I seriously feel like I'm in Disneyland here. Hey guys, Gavin Gear here from UltimateReloader.com. This is a rare opportunity. I'm here at Area 419. I'm sitting here with Jon Addis, the owner. Thank you for having me, Jon.
Yep. Glad to have you.
This is amazing. First off, I'm just blown away by what you guys have done with the company, and then walking into the facility and seeing robotic arms feeding material into machines and just all of the amazing things that go on here. What we're going to do in this video is give you guys kind of a rare look behind the scenes at the entire process of being inspired by an idea. The light bulb goes off in your head, going to the computer, doing some design work, thinking through some issues, and then from the design, figuring out how to program the machines. And we're even going to go out and cut some metal and really take the entire process end to end. And I'll have to say, Jon, you're really spoiled with the facility you have, the skills, the tools to be able to just take an idea and turn it into a physical product. What a totally awesome thing.
Yeah, and it's been like that for a while. Just very blessed to be able to do this every day, and it's what I love doing, and have all the right people to make it happen. So, yeah, let's jump into it.
Yeah. Okay, so what are we doing here?
So I had just an idea the other day to create another accessory for the back of the Zero. We've got this storage block already that you can store some shell holders, just miscellaneous tools, whatnot. Wanted to make a accessory to store a spare turret or two, or maybe three on the back, especially if you're not using the big dog stand, like an inline fab. That way you can keep the turrets close for guys that have spares. So
this would be awesome because those turrets are just sitting on my bench behind a machine, kind of at an angle, and not very elegant.
Yeah, we make the little base stand, but it just holds one, and you'd have to have a spot for it. So basically, idea in my head, I know what I want to do. I have a rough idea of how to go about it, especially makes it easier when we have an existing product, because what I'm going to do is I'm going to use this same clamp bar that we already make, and then I'm going to use all this geometry here that I've already gone and figured out. I'm just going to copy it from this, and then I'm going to work off of that.
Nice.
So,
and what program are we in here?
We're in Autodesk Inventor.
Okay.
And then we'll get into the CAM a little later, which is Inventor CAM. It's just a baked-in CAM system inside of Inventor.
Gotcha.
So let's jump into a new part here. Start a new sketch. And now I'm going to open this part, and I'm going to just start a new sketch on this part and steal some of the geometry. I'm going to project all these lines. Copy these lines. I'm going to paste them in here. So now I've got all the critical geometry for the ARCA profile, and then the clamp geometry. Park this here, rotate it, give it a constraint. So now this thing is fixed. So now I just want to start drawing off of this. What I know I want to happen is I want this thing to come off and be kind of a wing shape, because in order to get to this turret's going to have to be something like that, so that if we put two of them on here, it's going to clear each other. So I can kind of get a rough dimension of how far it is away from the center line of the ARCA and kind of work from there. So
that's really cool.
Yeah. Start working this into something that actually looks like a real part. Nice. Fill it there. Pull stud on the Zero is 1.25 inches, so I'm going to make this, call it 1.26, give ourselves some slop there. Let's get some measurements. Let's call it from the center line to center line here. So this is giving me, this X dimension is from the center line of the press over, 4.3 and 3.5. Now I also want to find out, I don't know on here exactly where the center of the ARCA is, so I want to find that out. I'm going to measure from this surface to the center here, 0.436. So I'm going to draw a line, constrain it to this surface, 0.436. Now I know this is the center line of the press.
So is this going to become a SKU at Area 419, or will you decide after you try it out?
Yeah, we'll try it out, and we'll decide whether it's going to work out for us or not. So I'll always start with the functional part of something, and then just start dressing it up so it looks like one of our parts. That's, I think, one of the biggest things that kind of set us apart a while ago is we didn't just make things functional. We made them functional and call it sexy. Like the billet, things weren't just like straight edges, nice rounded edges. We gave, when some had a long surface, we'd kind of break it up a little bit. So it's not always just making something functional. You got to make it look good, because just like cars, everybody wants a fast car, and it's got to look good too.
But I appreciate the fact that you guys make stuff also look functional. There's no lines that are just there for no reason, if that makes sense. Yeah,
exactly.
Yeah, elegance, but yeah.
So we've got a pretty basic
Nice.
part here already.
So this is a 2D that you're going to extrude.
Yep, 2D. I'm
Nice.
going to extrude it. I know the thickness of a storage block that we already make is 0.86.
So that's, I presume, a 1-inch slab, a
Yep.
plate that you're going to cut down.
Yep, and that's
Okay.
why it's 0.86 is we have to hold on to some part of the material. So a lot of times we'll work backwards from what I know I want to make it out of.
Like the
figure out
linkage arms that we
dimensions from
saw
there.
during the Zero How It's Made video. You got
Yep.
clamping on a rectangular surface, you mill one side and then
Yep.
flip it over. You have the exact profile of the part as a
Yeah,
clamping
we typically
device.
need about 1/8 of an inch to hold onto a part.
Gotcha.
Depending on what machine we're going to make it in. So I will dress this up a little bit with just kind of an ugly flat surface right now. So
I think you need some weight reduction on
yep,
this part, don't
do
you
need
think?
to lose some weight.
Let's make it speed oriented.
Offset these lines over, offset this circle.
How much enjoyment do you get out of the design process here versus like the CAM process to figure out the puzzle of how it'll be machined and whatnot, and tooling and all that?
It depends on the part. On a relatively quick part like this, it's probably like equal parts. Sometimes I get, when it's a part that has 100 tool paths on it, it gets a little a little extraneous just working through that, but I definitely enjoy that part a lot as well. We'll just cut a little pocket in here, put some fillets in to make it machinable and look better. Save it so we can assemble it in here and see how it fits. Constrain
When do
this to
you
my assembly.
when do you think about 3D printing something versus just going straight out to the CNC machines?
Almost never. I'm not a big fan of 3D printing. I mean, every once in a while I'll 3D print something, but it's never functional. Like I know it's never going to be functional. A lot of times that's what we're designing, is something that needs to be functional. So
Yeah.
I'll be honest, I don't even know how to use the 3D printer. If I want something printed, I send it to one of the guys to do it.
Gotcha.
And half the time, I can almost guarantee if I want to make something, I could make it faster on a mill than the 3D printer could make it.
Nice.
And I know it's going to be functional,
Yeah.
so we can actually test that part of it.
Yeah.
So just constrain this thing, and now we know that this will fit. Needs churched up a bit. Go back in here now, add some chamfers on here. We'll just create a mid-plane here and mirror this feature.
Can you steal the holes and whatnot from the rear storage block?
Yep, as far as the mounting hole.
Yeah. Where
Yeah,
the
so
arco
I'll,
clamp goes in.
Yeah, I'll just do it kind of the easy way, measure from here to here, 3/4 of an inch. Now, start a sketch here, constrain this to the middle, and dimension from
I
there.
assume you guys have favorite fasteners that you stick with and whatnot.
Yeah, A lot of
quarter
times we'll
20s and stuff.
jump over to McMaster, make sure something's there.
Yeah.
And then a lot of times it's thinking, all right, at this point we have almost every tap living in the machine, but not everything. Like probably don't have a quarter 28, so
Right.
if I can use a quarter 20 or a 5/16, something that we already use,
Yep.
just to save tool pockets in the machine and not have to plug in something special for a part.
Yep.
Whenever we can, we'll design to that, but it's never a limiting factor.
Well,
if
when
we
you have
need
up to
do
200
something.
tools at your disposal, that's
Yeah.
pretty awesome,
Yeah,
I'll have to say.
It definitely helps. Believe it or not, though, the Grobe is full. I mean, we make so much stuff on it now that
Yeah.
117 tools in that machine, and it's full. So
That's expensive to populate all of that. Holders and
yeah, at
tooling.
about $600 a holder, and who knows what on a tool.
Yeah.
That gets expensive.
Wow.
So now that I just clicked on that hole over there, basically everything populates over here. I can just use the last used hole, put a chamfer on it.
Is this a quarter 20 that we're doing here?
This is a 5/16 18. So
Oh, okay.
I don't ever model the threads on a tapped hole.
Mm-hmm.
We just model it at the minor diameter.
Mm-hmm.
That way we know what drill to use. Because if I
Mhm.
modeled this with threads in it and everything, it doesn't serve any functional purpose.
Right.
And it makes the drawings look more complicated
Right.
because you see all the section lines of it. So
Yeah.
this allows us to know what size chamfer to use and everything. So if I modeled it at the nominal diameter of a bolt, the chamfer wouldn't come out right.
Right.
So,
Makes sense.
all right. So we've got this part here. Looks like it's going to work. Now we want to jump into the cam of it. So,
Okay.
all right. So save a little time here. I got this assembled in our fixturing. We're going to just prototype this on the Grobe. That won't be where we will produce this when we go into full production.
Mm-hmm.
We'll do it on one of the horizontals on a custom fixture, kind of similar to how we make the rear storage block here. But just to get a part we can play with. I know we have all the tools in the Grobe. I can hold on to this and have zero custom fixturing involved. Just the easiest way to make this one off. So
You're showing material that's already gone, I presume. Like it's not in the jaws of the vise here.
yep. So here's our
Gotcha.
stock that we're going to start with. We've got a 7 by 1 by 3 piece of aluminum. So first thing I know I want to do is this is a pretty tight hole here that we're going to go in and finish with a 1/4 inch end mill. So I want to drill it out ahead of time. So I'm going to set our tool orientation. So for this to be the Z-axis, I'll select this hole and go find the right tool.
So the Grobe is a 5th axis machine, is that correct?
Correct, yeah.
So we have multiple spindles and we can rotate the vise and all that goodness.
Yeah, we can work on 5 sides of this part. Basically, we can work in every direction other than coming up through the table.
Gotcha.
We're going to rough it. Then I'm going to do a semi-finish pass with the same tool as the rougher. Let's leave 5 thousandths on that wall so we can come in with a different tool.
Is this the kind of program where you can watch the simulated tools going
Yep.
through and doing their thing? Okay.
Yeah, and we'll be able to see what's, like we can look right now and see,
Oh, I see. Yeah, cool.
jump forward, we can see how much stock we have left here. Yeah,
Give
this
us
is
a-
all
Gotcha.
in the setup as a fixture, so it looks at this as the model and everything else is the fixture. Do a finish pass on this now. Come over here and steal a tool path. So I can just copy a tool path right off of this part that we've already made, paste it in here. And this is basically how you work in 5-axis is you just set this tool orientation. So with nothing, it assumes the spindle is pointing down at the straight into the table. So every time we want to work off of that at a different work plane, we just pick a surface that becomes normal to the spindle of the machine. Here's what we're left with before this tool's going to come in here.
Oh yeah, just a nice little cleanup there.
Yeah, so it doesn't look like we'll snap it off.
What size end mill was that one?
That's a 1/4 inch, but it's 1 1/4 inches long, so that's not the strongest thing in the world.
Right.
So now I'm going to face this off. Make sure we're coming in off the part and not running into the vise. Yep. Duplicate. And flip our plane over. So now face the other side, just as easy as that. And a lot of times I'll pay close attention to the sequence of stuff, so I know I'm going to drill this hole from this direction, so I want to face this side first, this side second, that way it's not indexing the table in between tools, just to try to optimize time on everything. All right, let's see where we're at here. All right, let's drill this hole now. 287 tap drill.
Was that all of the stuff that you have loaded in the Grobe, that list?
Yep.
Nice.
There we go. That's better.
Nice.
So, kind of get an idea of just kind of knowing the size and what the spindle looks like on the Grobe that I think will clear, but we'll find out in complete. Rough this pocket out. Good. Duplicate. Flip it.
So that tool path came over as a mirror image, essentially, then?
Yeah, basically just copied this tool path and flipped my tool orientation to the other side. And
Nice.
I just want to change this. Things that don't really matter, other than bugs me when there's wasted machine movement that's cutting air, so it was starting up a little high. All right, now we'll just...
Are these like 10K spindle machines, or?
Grobe is 16,000.
Ooh, wow. That's like
then
Yamaha R6 RPMs.
Yeah. The DMG horizontals are 20,000.
Wow.
No, I take that back, 18,000.
Wow.
The NTX is 20,000.
So balance is pretty important on these tool holders and tools.
Yeah, we have to make sure we're using tools that are balanced for up that high, which typically everything these days is.
So that you can just shrink fit it and go, kind of thing, or?
Yeah,
you have to
we use a
balance
lot
in
of
here?
shrink. No, we don't. We don't do any balancing here. Pretty much everything is good for that RPM anymore these days. Should be pretty close to just needing chamfers now. Here's what I was talking about. Just this little chunk of stock's going to be left on, but just to make sure it works. Well, we probably will have to cut it off because the turret's going to run into it. So we'll just flip it over and cut it off.
Nice.
Looks like we're done.
Cool.
Now we just need some chamfers. So,
Does this literally just become G code for the machine then, or?
yep. Yeah, it's going to post out specific to the machine we're going to...
You're just sending it
Gonna
over the
do it
network to
on-
the machine.
It's going to open up another program here,
Okay.
and then we'll put it on a USB and take it out to the machine. All right, so we've got our Grobe here. Get rid of the sheet metal. Oops, wrong button. Generate all the code here. So this simulation, you're not going to see much because it's just going to run through and make sure there's no collisions. Made it through, means nothing crashed. Now we can run it through slower and kind of see everything that's happening.
That's a lot of moving mass.
Yeah,
Wow.
it's especially for how fast this machine is.
Wow.
The Z-axis moves at about 3,000 inches a minute. in rapid. The X and Y are around 2,000 inches a minute.
Wow. I mean, how much does this whole assembly here weigh?
I have no idea. It's got to be.
1,000
The machine
pounds
is
or-
33,000 pounds, so
Oh,
I would
geez.
guess this is a good couple thousand pounds here.
That's just
And this,
insane.
I mean, this is very fast in rotation and the y-axis. So pretty cool though. Shows all the everything happening.
Mm-hmm.
It checks the travels of the machine to make sure, like, sometimes if we're
So the previous program that we were in, the inventor cam thing, is that just we've got tools and here's tool paths, and now we're saying here's the specific machine that we're using. Now let's figure out
Yeah.
those nuances and stuff.
yeah, so we can go inside this right from design to cam. It's all built in.
Mm-hmm.
So we've got part designed, programmed, and our G code. Now we can head out to the machine and
Can we see the
Make
G
some
code real
chips.
quick?
oh yeah,
Like a text file?
yep. So this is what it spits out for complete.
Wow.
Doesn't mean a lot. Now if we open the file that I just posted out of complete, here's our G code, and just tell me line number. 22,000 lines of code in this one,
Wow.
and that's a pretty small program. If we open, let's say, let's do a scope mount. 76,000 lines of code in a scope mount.
Wow.
So not hand coding any of this stuff, but no matter what machine it is, all the codes look basically the same. G1s, G0s, and then just it's a lot of the other M codes and different things that become more machine specific. The Grobe is a Siemens control. All our other machines are FANUC controls, so there's a lot of different language between those two. But luckily we don't really have to worry about much of that. The cam does it for us.
Nice.
So very rarely do we have to go in and hand edit something. We do it occasionally, especially for the robot. There's some stuff we have to delete out and put codes in for it to work. But typically it's post and go.
Very cool.
So let's go make some chips.
Nice.
All right, we got our material cut, stamped for the Lang vise. Make sure we're on center.
So the stamping is an extra gripping feature, or?
Yeah, that's a Lang kind of exclusive thing. We have a hydraulic stamping unit that puts the same teeth that are in the vise into the
Nice.
part. Just tested it over here, and
Tenacious grip, huh?
yeah, I mean, it's been a game changer for us. We
Cool.
struggled early on with the Zero because it's so tall,
Yeah.
and we've got long tools working on it. But as soon as we switched over to Lang, that all went away.
Wow.
So
So tell me about the machine, John.
So we're gonna make this on our new Grobe G352. This is a horizontal 5-axis, which is a pretty rare breed of a machine. Typical 5-axis have a vertical spindle. This one comes in from the side. Advantage there is all the chips fall straight off the table down
Yeah.
into the conveyor.
Nice.
We literally never have to clean chips out of this thing. When we run production, there's a shower coolant nozzle that just floods the whole work area and just washes everything down. We won't run that here so we can see stuff, but it holds 117 tools, has a 16,000 RPM HSK spindle.
And you machine the Zero press bodies on this machine?
Yep, we
Yep.
make the Zero, all the scope mounts, scope rings, some of the ARCA parts. Very versatile machine. The work holding is the same no matter what part we run, so we can run it automated. We don't have to have any kind of custom fixturing, and it's just 5-axis is the way to go, especially if you're making a lot of different types of parts. If you're making just a ton of one part horizontal, 4-axis horizontal machine usually will win there because you can fixture a bunch of parts and save tool change time.
Gotcha.
But
Yep, like on tombstones or something.
yeah. For this, the ability to work on all 5 sides of the part in one operation is very crucial for us, especially scope mounts, 0, where we can put all the critical surfaces and features of the part in one shot. We don't have to rely on how accurate the second operation is for putting a feature on. So
very cool. We got tools loaded.
Tools are loaded.
Materials loaded. Okay.
And we'll run through this. I'd say I'd have about 95% confidence in the simulation we ran on the computer that I could just press start and let it go, but I'll ride the controls just to make sure nothing weird happens.
Okay.
So we're not out of machine for a couple days.
There she goes. So what are you doing with the machine here right now?
On the controls?
Yeah.
Or what's going on in here?
Like,
well, we're facing it now, but here I'm just holding on to the rapid, which is basically all the moves in between feed moves.
Gotcha.
So if I go to 0, it stops, but then when we get to a feed, this dial controls the feed speed.
So you just want to be prepared for something
Yeah, it's
happening?
mostly rapid moves that scare me. If it,
Gotcha.
for some reason it tries to go to the other side of the part and it's not there, it'll crash pretty hard.
Yeah, gotcha.
So I don't know why.
Okay, so that was our drilling move there?
Yep, that was pre-drilling that one hole.
With the coolant through drill?
Yep.
Wow, look at that thing go. That's your 1/2-inch end mill, is it?
Yep, that's a 1/2-inch rougher.
So if you were producing this part, the machine running would look pretty similar, would it?
Yeah. Yeah, I mean, I would probably bump up our step over a little bit because this end mill could take way more than I just gave it. But just to make sure I didn't break anything.
Is that still the rougher there?
Yep.
Okay.
Now we're taking the pocket out of there, just roughing it out.
You rough bored the hole, I see there, really fast.
Yeah.
Hogging material.
Yeah, I mean, sometimes we'll bring a drill in ahead of an end mill, but this size end mill we can just ramp down fast enough that it...
So you're just kind of going like this through the part then?
Yep.
Yeah.
There's our semi-finished pass. Now we'll go around to the other side. And again, here I could probably double the step over because it's not even thinking about it right now. Finish the walls of the pocket. Now we're We're going to finish our little ARCA clamping surface.
Ah, there we go. Tilting the table for that angled hole. Yep.
Yeah, we're good. Tapping. And chamfer.
Yeah, for some reason I was just waiting for this. This is pretty cool. Making the part look pretty, taking the edge off.
A little too much for one pass on that one.
Why are you saying that? Are you listening to it or?
Screaming a little bit.
Okay.
Yeah. That's a pretty heavy chamfer.
Would you slow it down or would you do multiple passes there?
Yeah, probably do 2 passes. A couple things we could maybe change to make it work better, but done.
Wow.
5 minutes, I was wrong. I bet if we ran it 100%, it would be 4 minutes.
That is mind-blowing. I am literally amazed. Looks nice, man.
Yeah. That chamfer doesn't look as bad as it sounded. Still a little chattery on there, but
Super cool.
safety squints on.
Now I completely get what you're saying about the 3D printing. When you can crank this baby out in 5 minutes.
How long would this have taken the 3D print?
Yeah, hours.
A couple hours.
Yeah.
So.
I seriously feel like I'm in Disneyland here. Well, I'm back here at the Ultimate Reloader shop and I'm still inspired by my experience with Jon. And I'm happy to announce that if you want a turret holder for your Zero Press, those are going to be available. This is my own limited edition prototype, but the production version, if you click on that first link in the video description, it'll take you over to the Area 419 product page where you can actually get this. Here's what I'd like to know is, what did you think of the experience of shadowing Jon Addis on the job? The CAD work, figuring out the cam specifics on the machine, and then actually cutting the part. I was pretty amazed and definitely inspired. I'd like to know what you think. And do you have a Zero? Is this a product that you would actually buy and put on the back to hold your turrets? Drop a comment and we'll start that discussion. Thank you very much for watching. That concludes this video, and that means it's time to wrap it up. I hope you enjoyed this video. Don't forget to like and subscribe. Also, we're on Facebook, YouTube, Rumble, where we've got unrestricted content, and Instagram. Make sure to follow us on all those channels. Ultimate Reloader also has a commercial solutions division serving law enforcement, the military, and the gun industry. We have some unique capabilities, including a comprehensive suite of recoil testing and evaluation capabilities, trigger profiling, and more. If you're interested in custom rifles like what we build here on the channel or gunsmithing services, you're going to want to go to rifles.ultimatereloader.com and get on the wait list. If you want to learn lucrative gunsmithing like what I show here on the channel, including building custom rifles and Cerakote plus a whole bunch more, you're going to want to check out the Colorado School of Trades, schooloftrades.edu. Thanks again for watching.